Okay, next we're going to be using the p-value method for solving the dependent t-test, and for this we're going to use practice problem number 18 on page 470. And we're going to be using the significance level of 0.01. We're testing the claim that captopril is effective in lowering systolic blood pressure. Be going through the steps that we have specified over here that we've been working with. So we're going to be checking our requirements for using the particular test that we have. So we're looking at here, we're told we have a simple random sample, and we're told also that we are to assume that these are a normal distribution. So we've met those requirements. However, if we're looking at our data, notice that we're looking at paired subjects. So we're looking at a before-after assessment. So that would make it the data paired in some manner. So that meets our requirements. So the next thing that we're going to be looking at here is, in this case, I'm going to skip down and actually do step 3, where we're pulling the alternative hypothesis out of the wording of the problem. As I've said, sometimes that helps me be clear in what I'm looking at, so I kind of do it both ways. You can pick and choose which order works best for you. But here, looking at this particular problem, we're seeing that the claim, testing claim, is going to be that the drug lowers the systolic blood pressure. So, looking here at the sample data that we have, and looking at we have before, after, and then we have the D. I haven't filled that in, but that would be the difference between each of those scores. So, if captopril does lower the systolic blood pressure, what do we expect the mean of D, that last column on the bottom, the difference, to be less than 0, or would we expect it to be greater than 0? So, if the values for the blood pressure for the before were consistently higher then the values for the after measurements would be would the UD be less than 0, as in a negative value, or would it be greater than 0? Well, it's going to be greater than 0, so they would be coming up with a larger amount. So if we're looking at, so that is going to be step 3, and then coming back up and looking at step 2, if in fact this doesn't change, if there's no difference at all, right? So then what would we expect our mu D to be? So if the drug has no effect, we would expect our mean of D to be equal to 0, because they would cancel each other out. So here are our two different statements, and then our next step of them together for our hypotheses. So here we have our null hypothesis is that mu D will equal 0, and our alternative hypothesis is that mu D will be greater than 0. Okay, so now that I have that, what is going to be my next step? What's the next thing I need to do for solving this problem? Well, I'm going to need to find my alpha level. So looking for this, and keeping in mind with these particular problems, of course, we're actually locating our alpha level. So what is going to be my alpha level for this particular problem? It's going to be 0.01, as again the significance level is the same thing as my alpha. And now I need to determine the p-value using statcrunch. So let's go through and look at using how we use statcrunch for calculating the p-value. So you're going to need to open your statcrunch. And once you have your statcrunch, you're going to need to enter all of the data and label it. Okay, so you need to have a column that contains before and a column that contains after. And then once you have that set up, you're going to go through and select stats, select tstat, paired, because we're doing paired, not two sample, but paired, and then you're going to select data. And you should get a dialog box that looks just like this. So you're going to have sample 1, you're going to select before, sample 2 will be for after, just as I have them set up here. And you need to pay attention to your setting up your hypothesis test to make sure those correspond with what you've already set up for your hypotheses. So your null needs to match what they have here. So here we're looking at the mu D equal to 0, so that is correct for this problem. And then you can see the alternative hypothesis mu D would be greater than 0, so you can see where I've changed the symbol there to reflect what's in the alternative hypotheses. So once I have both of those steps taken, and I do my computations, here is my p-value, which is 0.0001. Now notice again that using the statcrunch approach also gives me my t obtained. So my t obtained will be 6.371. Okay, so this is also can be used for getting your t obtained when doing the critical value approach, but with that approach you're still going to have to look up your t critical value in your table for the comparison. So now I have my p-value is 0.0001, and what is going to be my next step for this? I'm going to make my comparison, so I'm going to do my p-value and whether or not it is less than or equal to my alpha. So I'm going to take my p-value, 0.0001, I'm going to put it into this equation here and compare it to my alpha of 0.01. And then I'm going to ask myself if this is a true statement. So is this a true statement? Is 0.0001 less than or equal to 0.01 or not? Yes, it is. So I'm going to reject the null. Okay, so I'm rejecting my null. And now I'm moving into my last step. So what is the last part I've got to do here? So I've rejected my null. Now what do I need to do? Well, I need to restate it in the non-technical terms to address the original claim. So here's our hypotheses that we were working with. And then I need to take and look on the flowchart. And keep in mind, of course, we're using this bottom line here for writing up our hypotheses for these. So be careful about that. You make sure you're coming down the correct angle there with the way I've got them labeled for the dependent paired samples. And if we have that, then what we're going to see is that comparing, we would get this sentence: the sample data support the claim that captopril is effective in lowering systolic blood pressure. So this concludes our tutorial looking at the p-value approach. The last one we're going to have is looking at confidence interval.